In my previous tutorials, we have learned how to control an LED using the MFRC522 RFID module. And we have also built more advanced RFID project using the PN532 NFC RFID module, where we controlled 4 different LEDs using RFID tags. Today we are going to do it with different RFID reader, the RDM6300 125 kHz RFID module. Unlike the MFRC 522 and PN 532, which operate at 13.56 MHz, the RDM 6300 work at 125 kHz and designed to read EM 4100 compatible RFID tags. This makes it a popular choice for access control system, attendance system, and many industrial RFID applications. In this project, we will configure one RFID tag as the authorized tag. When you scan the authorized tag for the first time, the LED will turn on. Scanning the same tag again will turn the LED off. So without wasting any more time, let's get started with this project. We will require the following components for this project: Arduino Uno, RDM6300 RFID module, RFID tag, LED module, breadboard, and some jumper wires. Before we start building this project, let's take a quick look at the RDM6300 RFID module. The RDM6300 is a 125 kHz low frequency RFID reader that is commonly used in access control, attendance system, parking management, and security application. It is designed to read EM 4100 and other compatible 125 kHz RFID tags and cards. One of the biggest advantages of the RDM6300 is its simplicity. It communicates with microcontroller such as Arduino through UART serial communication at a default baud rate of 9600 bps, making it very easy to interface without requiring complex libraries. It's important to note that the RDM6300 is a read-only RFID reader. This means it can only read the unique ID stored in compatible RFID tags. It cannot write data to RFID cards or change their IDs. Also, unlike the MFRC 522 and PN532 modules that operates at 13.56 MHz, the RDM6300 work at 125 kHz. Because of this difference in operating frequency, RFID tags designed for the MFRC 522 or PN532 are not compatible with the RDM6300. You must use 125 kHz EM4100 compatible RFID tags or key fobs with this module. Now let's take a look at the pins of the RDM6300 RFID module. On one side of the module, you will find 5V, ground, RX, and TX pins. The 5V and ground pins are used to power the module, while the TX pin sends the RFID tag data to the Arduino. The RX pin is also available for serial communication, although it is not required for most basic RFID reading applications. On the other side, you will see another set of 5V and ground pins, along with the LED pin. These extra power pins make it convenient to connect with other components, and the LED pin can be used to drive an external indicator LED if needed. Finally, these two pins are the antenna terminals. The RDM6300 requires an external antenna to detect RFID tags, Simply insert the antenna wire into these two terminals, like this, and the module is ready to read compatible 125 kHz RFID tags. Now that you have a basic understanding of the RDM6300 RFID reader, let's move on to the hardware connection. Connect the VCC pin of the RDM6300 to 5 port of the Arduino Uno. Ground pin to ground. Connect the TX pin of the RDM6300 to Arduino digital pin 6 and RX pin to Arduino digital pin 8. Connect the G pin of the LED module with the digital pin 2 of the Arduino Uno and ground pin to ground. Now let's quickly understand how this code works. First, we include the software serial library because the RDM6300 communicate with the Arduino through serial communication. We then define a few constants that specify the size of the RFID data packet received from the reader. Next, we create a software serial object using the digital pin 6 and 8 and define the LED pin as digital pin 2. We also specify authorized tag variable, which store the unique ID of the RFID tag that is allowed to control the LED. In the setup function, we initialize both the hardware serial monitor and software serial communication at 9600 baud. We also configure the LED pin as an output and keep it turned off initially. The loop function continuously checks whether data is available from the RDM6300 as RFID data is received. It is stored in a buffer. Once a complete RFID data packet is received, the program calls the extract tag function. Inside extract tag, the program extracts RFID tag ID from the received data and verify the checksum to make sure the data is valid. If the checksum does not match, the packet is discarded. If the checksum is correct, the extracted tag ID is compared with the authorized tag with the authorized tag value. If both IDs match, the program toggle the LED. A 1 second delay using the minus function prevents the LED from switching rapidly while the tag is still close to the reader. If the scanned RFID tag does not meet the authorized tag, the program simply displays access denied on the serial monitor and the LED state remains unchanged. Finally, the hex str to value function convert the hexadecimal RFID data received from the reader into a decimal number so it can be compared with authorized tag ID. After uploading the code, open the serial monitor. Make sure the baud rate is set to 9600, which matches the baud rate used by the RDM6300 module. Once the serial monitor is open, bring your RFID tag close to the reader. As soon as the tag is detected, you will see information displayed on the serial monitor, including the unique RFID tag ID. This unique ID is what we will use to identify the authorized RFID tag. In my case, the tag ID is I have copied this number and assigned it to authorized tag variable in the code. Now whenever this specified RFID tag is scanned, the Arduino recognizes it as authorized tag and toggle the LED. If any other RFID tag is scanned, the Arduino simply ignores it and the LED remains unchanged. Now it's time to test the project. As you can see, the LED is currently turned off. I will first scan the authorized RFID tag. As soon as the tag is detected, the Arduino recognizes it, grants access, and the LED turns on. Now I will remove the tag and scan the same authorized tag once again. This time the LED turns off. Let's repeat it one more time. Scanning the authorized tag again turns the LED back on, showing that the tag can be used to toggle the LED state. And that's it for today's project. In this tutorial, we have learned to interface the RDM6300 125 kHz RFID reader within Arduino Uno and used an authorized RFID tag to toggle a LED on and off. We also saw how to restrict access so that only a specific RFID tag can control the output. If you found this video helpful, please give it a thumbs up. Subscribe to the channel and press the notification bell so you don't miss any upcoming Arduino, ESP32, IoT and electronic project. If you have any questions or suggestions, feel free to leave them in comment section below. I will be happy to answer them. Thanks for watching and I will see you in the next video.